So I'm Shoaib Mohammed Shahpuri, Technical Solutions Architect, part of the ATC Solutions Development Automation team. I've been with Worldwide Technology now for almost 7 years and have been focusing on application delivery, API security, automation, and recently I started focusing on to the distributed cloud services as well. So I'm based out of Seattle, Washington, and feel blessed to be surrounded by several beautiful mountains here and beaches. And I wanted to take this opportunity and wish everyone a happy National Mountain Day. There is a pic of my kids, Arsalan and Rumaisa. They are standing at the visitor center of North Cascade National Park. So that's from our recent camping trip. So let's take a look at the agenda today, right? So today we will be looking into the F5 distributed cloud platform, and followed by some of the use cases that it has to offer, right? Followed by that, we will look into a lab demo for the WAAP use case. That's a web application and API protection. It was basically an umbrella term that was coined by Gartner to demonstrate, the security needed by the web application, API protection, bot defense, and the DDoS protection, right? So what is F5 distributed cloud, right? So for those of you don't know, F5 acquired Volterra back in 2020, a company which was specializing in edge computing and distributed cloud services. And since then, they have been integrating all their services into this broader cloud, and they started calling it as a F5 distributed cloud services, right? So what it is basically a SaaS based platform which is supporting multi-tenancy and allowing you to set up various services like application delivery, security, network connectivity, across your public cloud and also your on-prem cloud providers, right? And that's for both monolithic as well as your microservices workloads, right? So it's a private application delivery network, and it has a point of presence across various geographical locations. So F5 refers to them as the regional edges, right? It provides you the necessary compute to deploy workloads at the edge location. And I think it uses a unicast model so that it supports fast response time and also allows the deployment of customer edge sites called as CE sites for public and private workloads. We'll see more into it when we discuss the use cases. So let's take a look into some of the use cases, right, that are offered by the platform. The first one will be the app delivery network like. So like I mentioned, it offers you computing at the edge. So you basically deploy and deliver your applications closer to the edge, right? It can deliver your applications that are hosted across public or private clouds. So for traditional big IP users who have been using big IP, right, this will be similar to setting up your virtual servers, your pools, your monitors, right? But without standing up your infrastructure and not having to deal with those code upgrades, right? The next use case is a multi-cloud networking, and we have seen oftentimes the applications that are deployed across the multiple clouds for various reasons, right? It might be due to governance, or maybe one of the team within your org likes the AWS versus the GCP, or it may be to utilize the better feature sets that are provided by AWS versus the GCP, right? Whatever may be the reason, it always introduces a lot of complexities. There's a lot of tool sprawl when there's various cloud providers involved, and not to mention the technical expertise that you need to manage all of these providers, right? And I think the classical problem that we have been running into is the overlapping IP address. So the multi-cloud networking solution provides you to manage all these complexities from a single interface, right? So that's one of the main use case for the distributed cloud environment here. Like I mentioned, WAP. So WAP, once your environment is now stood up, right? So you can layer the security basically to protect your APIs against various exploit. It uses same policy engine as that of the WAF, and it discovers your APIs using the live traffic. You can implement the bots solution either through the WAP, or you can also implement it as an independent solution as well. Next slide. So let's take a look into the demo environment, right? So, all right. So here is a moment of truth for me. So I'm going to be putting my neck online, a little bit of prayers there for me. So I will be demonstrating the WAAP use case lab that we have built on the ETC platform, and we are using a dedicated XC tenant, right? That's assigned to the WWT by the F5. And as soon as this lab is launched, webhook gets triggered that automates the creation of users on the XC platform, right? So the lab, in this case, uses the distributed regional edge to deploy a star ratings application in a managed Kubernetes cluster, and then layer the WAAP security, right? And if everything goes planned, we will be testing the security posture using a security tester tool and send some malicious traffic to showcase the results. So let me open up the lab page here quickly and walk you through the lab. Yeah, so this is the lab. So F5 Distributed Cloud Web Demo Lab, right? So this lab basically uses two approaches. One is your NetOps approach, wherein you log into the web UI and basically walk through the entire interface. So you have a self-guided lab guide, and if I take you through the lab guide, right, you can see that whenever you log into the F5 Distributed Cloud for the first time, this is a screen that you will be seeing. Accept and continue, and then depending on your role, you'll basically set up your role, like whether you are a NetOps or a DevOps persona, right? So you set up your role, and once you set up your role, this is how it should appear to you, right? And if you start browsing through the lab, the first step is where you will create your token, right? Once you create your token, uh, you will then go through the automation steps of creating the token. So the lab basically follows, like I mentioned, two approaches: the NetOps approach, which is very useful for new users who are new to the platform and want to learn the F5 distributed cloud platform. They can certainly use this approach. But for the more advanced user, we also have a DevOps approach or automation approach where we are automating the code, right? I mentioned about the security tester tool. So we can leverage this tool and just deploy the application and test the security posture. It should show that the application is vulnerable. And once you apply all the necessary WAAP protections, you can then later test the security policy and identify that this application is protected. So you can also review some of the dashboards for the application, right? So having said that, let me pull up the Visual Studio Code for the for the demo. So for the ease of manageability, I downloaded the GitHub code to my laptop. So I will be walking through the lab from my integrated environment. But when the users launch the lab, they will be having access to the GitLab instance within the lab from where they can download the code and basically start executing the manual approach, by logging in the UI or by using the automation approach. So me being a member of the automation team, I would use the latter approach, and also in the interest of time. So let's start deploying the code. And then once the code is getting deployed, I will basically walk you through the steps. So as you can see here, we are using collection XC Cloud Module collection and using the Kubernetes core module. I need to give something called as the API token and then the XC tenant. So this is the WWT tenant, like I mentioned, the wwt.console VAS-Volterra.io, which is dedicated to WWT. You need to deploy the application to a specific namespace, and the namespace that we are using here is star ratings, right? And then this is a dummy domain, which gets assigned to a CNAME, so you can use the CNAME and then basically access the application through a public interface, right? So the first step here is fetch the current details. You create your namespace in the tenant, right? And then you create a managed Kubernetes cluster using the create v8s module. Once that is done, you extract the kubeconfig file. Once you have the kubeconfig file, you are deploying the application using the manifest file that's present here. Once that is done, you are creating an origin pool. The origin pool is similar to a pool in a big IP, right? But now here you are pointing that to a service that gets created inside the XC tenant for that application. You'll then create a load balancer instance for that application, right? And once that is done, you'll create a bunch of security policies like the app firewall. You'll update the load balancer with those policies, right? So you'll use a Swagger file. Like I mentioned, we are implementing the WAAP use case, right? The WAAP use case also allows you for the API protection. So we are using the Swagger file to provide that positive security posture. So it only allows the API calls that are valid through the Swagger file, right? You create your API definition, create the service policy, which is similar to the AWAF policy that you would create in the big IP, right? And you associate all that to your HTTP load balancer instance. Create a bot defense configuration, and also create your DDoS configuration, right? So this is how it flows. Let me log into the XE tenant here quickly and showcase you, right? So once you log in, this is where you would come. Let's go to the distributed apps and try to explore. Yeah, it logged me out. Let me log back in. Yeah, so make sure you're in the right namespace. Once you are in the namespace, so this is the demo Kubernetes cluster that it installed for us. So click on it, right? And then maybe you'd want to click on deployments to see the various deployments it created, right? And then if you click on pods, you can see that it deployed pods across all the points of presence. Since we selected a virtual site, a shared virtual site, which will deploy this across all the points of presence, right? And then you will have a click on service. So this is the service that the load balancer will be load balancing to. Let's go back to the WAP instance and go back to your security ratings. And then here you can see the HTTP load balancer objects that got created. And if you click on manage configuration, edit, right? So you can see the star ratings. You can see it's a HTTP virtual server which is listening on port 80. You have your origin pool attached to it. You have your web application firewall rules applied to the same load balancer object. You have the bot protection enabled, right? You have the API protection here enabled as well. And then you have the API discovery and DOS protection along with the various other policies, right? So let's go back here. And then if you take a look, let's go through some of the dashboards, right? Security dashboard. Let's try to attack this application. Okay. Hopefully it is still loading. Yeah, the app is still up. So let's go here and copy this and try to send some malicious traffic and start the test. You can see that we sent a traffic for threat campaign. It was blocked. SQL injection, predictable resource location, which is your post processing, and some of the CV exploits as well, right? So let's take a look at the API security in action as well. That seems to be protected as well. And then the bot defense posture. Yeah, so the bot defense is basically trying to jack up the ratings for one of the item in this application with the item ID. And you can see the status is blocked for everything, right? So let's go to the dashboard and maybe review some of the events and try to pick up the logs. As you can see, there are two threat intelligence, and you can see the bot traffic here, right? And it should show up the load balancing objects at the bottom. So once you click on that load balancing object at the bottom, yeah, so it should take you into more greater details. And I think one of the things which I mentioned about the API endpoint, so it does all the API discovery for you. And this is how your API graph look like, right? So either you can use the graph or the table, and you can see which are the top attacked APIs, whether any sensitive data was leaked or not, what were the total number of API calls, right? So you can look at malicious users. You can take a look at the security analytics and basically filter the analytics or arrange the analytics as per the event. So you have a bot defense event here, and you can go into more greater details into the logs through the platform, right? You can click on bot defense and observe some of the bot defense capabilities that it has to offer. I think that's all I had for the demo.